I am Brad Keelor. She is Alba Yerro-Colom. Coming up next on Director's Cut, you're going to hear about her complicated relationship with ceiling fans. Hello again, everybody, and welcome to another episode of Director's Cut. My name is Brad Keelor. I'm the director of the Geo-Institute, and that is why we call this show Director's Cut. Every single week, except during the summer and maybe a week or two at the holidays, I sit down with a different GI member who has many stories to tell. Some of them are personal, some are professional, but all of them are fun. If you don't know anything about the Geo-Institute, after you watch this here interview today, cruise, walk, type, I guess, over to geoinstitute.org, and there you will find out many things, including that we are a technical society with about 12,000 members, most of whom are geotechnical engineers and or geologists, and that we are part of the American Society of Civil Engineers. And if you like what you see today, and I think you will, you should click like, subscribe, and get notifications, and we will let you know every last time we post something to the YouTube channel. Hopefully you saw our 5th anniversary episode of Director's Cut yesterday. If not, you can go back and watch that anytime, along with all of the other previous episodes on the YouTube channel. With that out of the way, coming to us from across the Atlantic Ocean, normally she would be in the same state as me, but across the Atlantic Ocean, she's a faculty member at Virginia Tech. It is Alba Yerro-Colom. She's on sabbatical right now. We'll tell you a little bit more about that later. Alba, thank you for doing this.
Thank you, Brad, for inviting me. It's an honor.
We have 10 questions, just like we do every week. 2 of them are the same as they are for everybody, and we must begin with one of those. Describe your job in 45 seconds.
Okay, so I'm an associate professor of civil and environmental engineering at Virginia Tech, and I'm a geotechnical engineer. I teach undergrad and graduate courses, so I have I'm lucky to be in front of these great students and future geotechnical engineers that will drive the world in front of us very soon. And I also do research. So in a very general terms, I try to develop solutions that enhance infrastructure, safety, and community resilience in general. And I have the chance to work with great colleagues, not only at Virginia Tech, but also internationally. And finally, I also do some service to the community and like being part of different committees, technical committees, and also as an editor or associate editor of some journals. And I think that's it.
So the first follow-up question is this. I think about the way I was when I started undergrad. I was 17 years old. I think maybe that's all I need to say about that. And then when I started grad school, I went straight through, but I was 21. And I feel like I had a much better handle on what was happening when I started grad school than when I started undergrad. How do you approach that difference as somebody who teaches both the undergrads and the grad students?
So how do I see the difference on the students? Or how?
Well, and how do you work with the students differently,
Okay.
I guess, because they're also there for very different reasons a lot of
Yeah.
the time at those levels.
So my interaction with undergrad students is mainly in the classroom and also during office hours, but I try to engage them in the classroom and try to guide them a little bit, but in a more general way. Instead, for graduate scholars, I try to talk more about research and like more in detail related to the actual geotech application. No, so if you start like giving them too much detail, I think at the undergrad level, sometimes they don't get excited. I think it's the opposite. So you need to just sell them like the big news and the big applications, maybe how fun is our world. I will, yeah, so like the geotech field, it's you need to sell them a little bit that, no? I think that those that choose geotech, they are already motivated for that one, no? But undergrads, it's a little difficult, I think, to engage them and are more immature at the same time. So they still need to decide. Yeah, I don't know.
I like
I
that
think
though.
depends student to student, and I think every mentoring, uh, so mentoring, I think is so individual. You cannot apply everything to all the kids or all the students at the same time. It's very personal, I think, like one-to-one.
But I do like that answer because it made me think about when I was an undergrad, and if I got too much information, you're right, I would kind of turn off and I would think I don't really need to know this. It's only later
Exactly.
on that you want to get further into a topic. That was a really good analysis. I like that. And we'll talk a little bit more about intro to geotech specifically later on in the interview.
Okay.
As we record this, I am 1 day away from turning 46, and every year around my birthday, I think I'm getting old, and I think about generational differences a lot. So, Alba, you are the lucky one that gets this question. When you're older, what do you think you will complain about the most about kids today?
Okay. So going back to your question, when you say you grow older, I don't think I need to grow much older to complain probably about kids today. So maybe I can just talk about what I feel right now. But so I think that they are involved, they are facing this uh, social media, they are involved in this technology, and then so they need to live with this all the time, no? And they need to grow together with this, I would say, fast-paced media that maybe shortens their attention spans. And basically, I hate this because they don't have, so they lack of patience. So they don't have patience. They want everything instantly. Like they want likes, they want answers now, they want results now. They are lacking this patience that I think we used to have older generations. And I think this patience is essential for long-term growth. This will help people, or this helps people overcome challenges, like, or build self-confidence, develop resilience through this sustained effort. And I think this is super important. So I just complain already about this lack of patience. I talk also about my kids, but also about students. I think that a few seconds is already too slow. No, if something takes a few seconds, and so I think like 10 years from now, I will still complain about this, or this something negative about technology and this like social media life that they have. On the other hand, though, the other side of the coin is that I think that this fast life that they are having, this also gives them this ability to multitasking. If they are get well trained, I think they will be much better than maybe me or like older generations at multitasking, at doing many things at the same time. And if they can balance all of this, they will be much better than us. So I guess that every single generation needs to, I don't know, like to grow and learn from the pros and cons of their, I would say, generation, no? Of their times. So yeah, lack of patience. I think that's the worst part. But I
think,
will probably buy multitasking and these things.
I think for me, it's always like just having the data, period. I think about writing papers or assignments when I was in high school, and some of the information that we would have wanted to include, there was no way to get that information easily. Like, even if you could go to the library and in theory you had access to it, it was going to be at best a little bit outdated. And how do you judge when you have access to all the world's information at one time? Somebody leaves something out. It's human nature, right? But we kind of fuel it by almost punishing people for not knowing stuff or being aware. Oh, this could be an entire show on its own. The third question is always the research question, and we're going to talk numerical modeling a little bit today. And whenever we talk about numerical modeling on Director's Cut, I like for the guests to kind of demystify it a little bit for people, and make it a little simpler. And just by chance, that's what you're going to talk about today. Numerical methods, numerical modeling for practice. How do you apply this in the real world? And that's all I'm going to say. And Alba, you're going to take it from there.
Okay, thank you, Brad, for this question. I like that you're giving me the opportunity, because part of my research, but the main part of my research is on developing new tools or advance the existing numerical frameworks, but to address other problems that maybe 20 years ago or 10 years ago we couldn't investigate or understand because of the lack of a good numerical framework. All numerical frameworks have issues, have flaws, have problems, and there is no numerical framework that is good for everything. So that's for sure. On the other hand, like what I would call classic numerical frameworks, such as the finite elements, I know that this is well established in practice now. Maybe it's not done like every single day in every single office, but I think that it's well established and it's fundamental, knowing how to use finite element methods for the understanding of current, like most the geotechnical problems that we need to face in a daily basis, especially for those that are problems that are a bit more complex. The use of numerical tools is completely justified, no? But right now, and during the last 10, 15, 20 years, finite elements have been improved, or other techniques around finite elements have been developed. And I feel lucky to be part of this generation that we were able to experience and to develop part of these numerical tools. One of them that I've been involved is in the material point method, which tries to basically solve the limitation of finite elements to simulate large deformation. So you know that with finite elements, as soon as you have the failure, like if you think about the slope of stability failure, as soon as it fails, the problem or the solution breaks, and then you don't get convergence, and that's it. And at some point you might think, okay, this is everything I need to know. I just want to know if this will fail or not. But eventually we might be more interested on, okay, if it fails, what is the consequence of this failure? So, and in this case, to analyze and to better assess the risks and the hazards that this event can basically develop, you need to take into account other frameworks, or now we have these frameworks that are available that up to now maybe they were only available for academia, for researchers, so we were basically developing them. But I think now they are pretty ready to start like for non-academic positions, so like industry or more practitioners to be used. This is a difficult transition because for a framework to be accepted in practice, it needs to be super validated. It needs to be well accepted in the field. And this is hard for us, for numerical developers, because we love to see our research to be practical and to be impactful, no? And I think one of the important things is to do outreach as a researcher, to do this outreach and to this to explain the community that these tools are available. For instance, one of the softwares that I am highly involved is called Anura 3D, which is using this material point method, which is very good for the study of larger formations and soil structure interaction problems involving larger formations. And something important is like not to develop only these softwares and just put them online, because these are, for instance, these are open source, but also provide practitioners with resources such as like tutorial manuals, a friendly pre-processing or post-processing, maybe YouTube videos that train them on how to use these tools, and just make sure that practitioners feel comfortable using these more advanced, and basically explain that this is one step forward, like moving forward with finite elements. But yeah, I think that this process is very exciting for me, like being part of like in the academia, like from as a researcher, like seeing that something that once was very theoretical, now it's becoming more useful for practitioners, no? And like receiving these calls from, I don't know, from some from industry and colleagues saying, "Oh, I've been using your software, the software that me and my colleagues from the community are being developed, and we've been using that for this and for that, and it's very useful." So it's very nice to hear that it's useful for the community, you know. And numerical methods are not just left there in a drawer of your desk, but they are really useful for the community, you know.
Oh, I like that. That's a good walkthrough, and we will put a link to your software down in the show notes below the window where everybody is watching this right now, so you can check it out and not be intimidated. That's an important part.
Yeah.
So you grew up in Spain, spent time in the UK, been in the States, traveled a lot. That's the life of an academic, right? Alba, I wanted to ask you, what life event made you realize either that the world is much smaller or much larger than you previously thought?
Okay. So, well, when I was little, I felt that the world was huge, you know. And I used to live in this small little town, like 5,000 people. But I was lucky that my family loved to travel, like internationally. And at the end of every summer, I could hear the story from my aunties, my uncles, and my grandmother. Also, my parents, they loved to travel, and we did as a child. But it was always like, okay, we were always going back to your little hometown, which was your main world, like your little world. And then you could see these far countries, like these different cultures, but these were like, oh, this is the world, the outside world. And I felt that the world was huge, no? So I was aware of these other parts, but it felt impossible to I don't know, too big for me, no? And then as soon as I started traveling, but not as a family vacation, but going, for instance, for the first time in the UK, and I lived there doing my postdoc, no? So it's like now your home is not just your little town, but now the boundary becomes larger. So the rest of the world becomes smaller, no? Because your home, it's a bigger space, because it becomes, I don't know, like Europe became home for me. So the world was becoming smaller, because world is always like the outside your home. And then, especially after moving to the US, world became because my home became bigger, because it's like home is now, okay, Spain, so Europe, UK, but also US, it's home for me. So I feel comfortable in that area. The outside world became smaller, no? And then I think that also after COVID, that we have all these online meetings now. For instance, right now, no, I am in Spain during my sabbatical, and we're having this very real interaction. It's like, oh my God, now suddenly the world that used to be so big, now the distance became like almost nothing, no? Because we can, I don't know, like interact with all these people from around the world, that it feels much smaller than used to be when before I lived in other places, no? I don't know if I'm answering your question or not, but
No,
there
I
is
think
no
I think so.
single. That is so. Your question, I think, is like, what event was make you realize it's not just an event.
Yeah.
It's been like probably many people had this same experience, no? But as you grow older, the world becomes smaller. But yeah, especially when I went to the US and I lived out abroad for a long time, and the technology that it feels that everything is much closer. You can just meet with anybody around the world, and I don't know, it's beautiful, no?
And even though this is the case, we still have many, many cultural differences
Yeah,
across the world.
yeah.
And this is where this next question came from. I try on Director's Cut to avoid the obvious ask a foreigner about something American questions, but I felt that this one was just too good to pass up. And it turns out you've got a pretty good story about it. So, Alba, your American question. Ceiling fans, friends or foes?
I have both. I thought they were friends, but eventually they become foes. Absolutely. So growing in here in Europe, we don't have ceiling fans in general. I never had ones at home. We just had these little fans that in these hot summers in Spain, you need them just to refresh a little bit. And moving to the US, we bought this house and it was so fancy because they have like this, you have one fan in each room and then this fan in this tall ceiling in the living room. So we were very excited about that. And then, so I thought, oh yeah, I love ceiling fans, no? They are so nice. And this design, blah, blah, okay. Then it happens that it's summer and you try to turn on the fan, the ceiling fan, the one that is really high in the ceiling, and it didn't work. So it's like, okay, my husband says, okay, maybe it's the motor, the remote, something like that. And then instead of like asking for going to Lowe's or Home Depot to get a replacement, we said, no, we can do it ourselves. So my husband like bought this new remote control. It's like, okay, we have it at home, the new remote. So we just had to switch or change the little sensor, like that, and connect that to the fan. It's like, okay, how do you reach that high? I mean, it was impossible just to reach that high. So like, okay, maybe with a ladder, I went down like three houses down the street where this geotech faculty, like Dr. Joe Duff, who lives down the street. We also asked Adrian Rodriguez, who is also my neighbor. Anyway, I don't remember where we got this tall ladder, but it was not tall enough. So what do? It's like, okay, so we got this table. We have this table that we have it outside on the deck outside. It's like, okay, let's put the table inside. Like, of course, we had to move all the couch and everything. We put the table, and we had the brilliant idea to put the ladder on top of the table. So it's like, are you sure? My husband and I was like, yeah, we can do it. The kids were running around, So probably not the safest example to our kids to do, but we decided that he should climb up the ladder. I was holding the ladder, like that
A
was
very
the
important job.
safest
You have to
thing,
hold the ladder.
Exactly, hold the ladder. My husband on top of the ladder, trying to change the whole thing. He couldn't eventually, well, like going up and down because it was so tiring to work like with his hands up on the kids running around, like, please don't watch. Anyway, and then eventually we brought the whole fan down. Like, oh, we almost, I mean, my husband almost killed himself, but I was there to support the ladder. Anyway, so we brought the fan down. The motor was working. There was also a light or something like that. We changed the sensor. Everything was apparently working. And then my husband just risked his life again to bring the thing up again. I don't know. We spent days doing that, like trying to do the whole thing and back and forth. So eventually he brings the whole thing up again. I started hating the whole stealing fan altogether by then. So we connect the whole fan. No, not we, he did, but I was holding the ladder just in case again. And it still doesn't work. So after doing the whole thing, the only thing that we could do is like now the light works. So the light, there is a light at the bottom, it turns on. The fan doesn't spin. So anyway, we just decided not to use that fan anymore. It was just a so traumatic experience, so risky, and I don't know, like eventually if one day we want to use that fan, we will call someone or something like that.
I feel like, though, that everyone has a ceiling fan in their house that they don't use for some reason.
How do they change these super tall ceiling fans, no? And I don't know, I really don't use them. They were super, like, I was very happy to have them, but I don't really use them. Even those that I have in my room. I don't know.
The most important question, I think, that comes out of all this, does everybody on the geotech team at Virginia Tech live in the same neighborhood?
Oh, no, we are actually 3. We are maybe 8 or so. So 3 of us, we live in the same street.
Wow.
So it's like 8 neighbors or so, or 9 neighbors, and 3 of us are geotech.
So if anybody's ever in Blacksburg and you're looking for, well, if you just want to hang out or if you need some geotech advice, you can just get it all covered on one street. That's amazing.
Yeah.
So the other question that we ask every single person when they come on Director's Cut is, how did you first get involved with ASCE and GI?
Okay, so I think I heard about ASCE before moving to the US, and especially when I was preparing for the interview, you have to say, oh yeah, I will do that. I will get involved in this and that. And then back then I knew I had to be involved somehow with ASCE and in particular in GSI, with the GSI. But short after I moved into Blacksburg, I just landed there, and I remember in particular Dr. George Fields just knocking on my door. I was in my office, like, oh, can I bother you? And he was just checking that I was okay, and I was everything was good. And he said, oh, by the way, it's very important that you get involved into ASCE and GSI and GI and anyway, and I remember this, and after him, also other colleagues, Adrian, but also Russell Green, and back then Nina Stark. I remember some of the conversations that they were involved in some different technical committees, and then also we have at Virginia Tech, we bring all our graduate students to the geo-congress every year. So yeah, it was as soon as I landed at Virginia Tech that I got involved.
Oh, that is fantastic. Lots of shout outs there to people in the geotech team, and even a former member of the geotech team there, but special shout out to legendary Professor Phils there for bringing you into the ASCE and GI fold. Now, we are not breaking any news here. You are from Spain. We've already talked a little bit about that already. We're going to get into it a little bit more now. People can tell maybe by your accent that you are from, well, you said you're from a small town, but you've got to be from somewhere near Barcelona because of the accent, right? We need a little bit of tourism advice here. So, Alba, fill in the blank. Everyone's first trip to Barcelona should include what?
Many things. So, Barcelona is it's a very pretty city. You have many different things from architecture to food to culture. Inshore, like if I have to go short and you have just 1-2 days in Barcelona, you should just go to experience and to see modernism art, which is this architecture that was developed end of the 18th century and beginning of the 19th century by one of the most famous architects was Autori Gaudí, who designed the Sagrada Familia, which is this big church that it's still unfinished, but hopefully will get finished in the next year or a couple of years. So it's very interesting because it's also a UNESCO World Heritage Site. But from the same architect, but also other architects that were that developed their designs during this period. Like in Barcelona, you have many different areas that you can clearly see the basically this beauty and these great buildings. It's not only Sagrada Familia, but also parks, or Parkway, or La Pedrera. So it's there is many different like little places in Barcelona where you can enjoy this. No? On the other hand, for food, find a restaurant that it's not open at 6 p.m. for dinner, please, because this means that it's for tourists. But you shouldn't. Spanish people, they don't go to dinner at 6 p.m. You should go to those restaurants that open maybe at 8 p.m. or something like that, just to make sure that it's where local people go and enjoy, I don't know, a paella or something like that near La Barceloneta, which is in front of the sea. And it's very, very pretty. And then if you stay a bit longer, I would encourage you to find, and if you want to know a bit more about the culture, not only Barcelona, about the area and the Catalan region, we have this, I like to explain this, but I think it's very impressive. It's a tradition, it's a Catalan tradition that we do, which is we build human towers. And there is plenty of groups, we call them colles, that we train and basically to build the tallest and most difficult human tower that you can imagine. So we have like towers that we have like maybe 10 stories, like the tallest is 10 stories, one on top of each other, but different structure, like 4 people per layer or less or more. And then some of the big towers, you need maybe 600 people to build the whole thing. And it's very interesting from the geotechnical point of view, the way how we build those towers and with just people, no? Like people like actually you use any kind of like people, like short, tall, little, thick, I don't know, women, men, children, everyone is welcome in these constructions. And they are very impressive. If you look at them, the way how we build a foundation underneath each pillar, each column, we literally build a foundation, a human being foundation. Like literally we mimic something that we do in practice, but we build that with human bodies, right? and the way how we redistribute the stresses. I think that from a civil and geotechnical perspective, it's super interesting and it's impressive. I recently had a friend watching one of these exhibitions. We have exhibitions from mid spring to mid fall, and we have exhibitions almost every weekend in some place, maybe not in Barcelona, but somewhere in little towns around. That is like 60 or maybe more different teams. Of course, different like difficulties. Like some teams are really good at doing those, others are less good. But everything, like if you have the chance to go to Barcelona and just please go and try to find out if there is one of these exhibitions in the area and go and see them, because it's amazing.
And what a great job looping civil and geotechnical engineering
Isn't
into the
it?
answer there. That was fantastic. And so
Yeah.
this is another easy one. We'll put something from YouTube in the show notes below so you can watch the human towers being built as well. It is a super cool thing to check out. At the very top of the show, we talked about some of the differences, again, between undergrads and grad students. Part of the thing that got me thinking that way is you teach Intro to Geotech. And so, Alba, here's your second question about this. What 3 things do you generally hope students take away from that course?
Okay, the first one is to let them know that we exist. Okay, because as the students, as the first day in the class, they don't even know what geotechnical engineering is, so they have no clue. And just convince them that we are doing an important job. They need to know that soil is not just dirt; it's a complex material and our job is to control the stability of our infrastructure just by understanding how soil and the underground works. No, so this is the first thing. The second thing, and this is a little bit more technical, I try to show them I really want them to know the importance of water, the importance of water in soil behavior. This goes from affective stresses, like affective stresses is a must. I tell them on the very first day when we cover affective stresses, if you don't know what affective stress is, you cannot pass this course. And particularly the importance of water. And I think that hopefully they leave the course knowing that. But it's not something that it's obvious maybe in the beginning, but as soon as the course moves forward and the role of water, in hydrostatic condition, with flow, in the consolidation module, so you see the different roles of water, how it plays into the geotechnical or the soil behavior, no? And then you said 3. The last one.
You could do 8 if you wanted to.
Yeah, I can. No, but the last one, I try to give them a kit with better skills for problem solving. I think we are very lucky because Intro to Geotech is a lab course, so we have the lab, so they have the ability to do the experience in the lab and play around with tests and have that. I think it helps. But basically the idea is to give them the fundamental concepts, the tools, the methods to solve geotechnical problems. Maybe they don't know how to solve them yet, but they should be able to connect all these different items in this toolkit, right? So yeah, I think these are the 3 things that.
And that is a good summary. So, we still need structural engineers, but take that, structurals. We've got people who want to learn about soil too. I like that. The first one, though, very important, just the awareness. We hear this a lot.
Yeah.
It's not just a problem that's relegated to your campus. So maybe we need a campaign, little buttons, tell somebody about geotechnical engineering today.
Yeah. Every day on my first day of class, I have this, I do this survey, and the students, they answer. So they, with their phones, I have this QR code, so they answer with their phone. So we see the answers on the screen, and my first question is like, okay, do you know what geotechnical engineering is? And then they can say yes, no, or a little bit, no, like something like that. And then most of them, they say no, like 70%. And then I ask them, so when you grow up, in which field do you see yourself working? And then I have these different options, no, like structural engineering, like the classic topics, no, in civil, also land development. Now everyone is in land development. And then even in a class of something between 40 and 80, it depends on the semester, I get maybe one person, two people answering that question that they are interested in geotechnical engineering. It's so few, like only very few students. And then I tell them, okay, if I can engage just two people from this class more into geotech, I have succeeded, you know. I just try to get them involved, but we are starting from very low. I think you start from very low because they just have no clue and they are really not interested. In general, I don't want to say everyone, but.
So we go from engaging the civil engineering students and getting them to geotech now to a more general public question, which in some ways is even harder. I saw the phrase landslide prediction on your LinkedIn page, and immediately I thought, oh, this is a perfect opportunity to ask this question. How do you explain landslide prediction to someone outside the field?
It's so difficult. No, but because
that's why we're asking the question.
Yeah, I know. So I would say, so is the research, so landslide prediction is a research field tries to answer one or more of the following questions. Where a landslide will happen, when it will happen, how much material will involve, how fast the landslide will move, how far the landslide will go. So, and this involves, so in order to answer every single question, it's a huge research field that we can discuss forever, no? Like, and it's involving also different disciplines within our own field, no? It's like some part maybe it's more geological engineering, sometimes some parts are more geotechnical engineering, no? Like you have all this. But like really answering all these questions at once, it's impossible at this point. So prediction, if we think prediction, we can think about like answering all these questions at once. And I think it's an ideal situation, no? To really know when a landslide will happen, where, how much, how fast, how far. Maybe if you are in one particular location and you are specifically, if you have a slope that is monitored, you have like different ways to assess that and to know, to answer at least one of these questions with more or less accuracy. But overall, it's so difficult to answer, no? We are getting closer and closer maybe to get better answers for different regions, for maybe one specific slope. it's very deep. So each case is a little bit different, no? But yeah, I'm trying to work on this topic because it's so complicated.
And you can't give the public what they want because
Exactly.
people want to know, if I build a house here, can you guarantee me that there's not going to be a landslide in the next 100 years? And of course, you can never guarantee 100% that that's not going to happen. Oh. The final question. We try to educate the people on Director's Cut. That's what we've been doing here. You are, of course, on sabbatical for a year. You're in your native Spain, and I never thought about this until a couple of years ago. There are still a lot of people in the world who don't understand what sabbatical is. So, Alba, can you explain the concept of sabbatical to those outside academia, and then tell everyone what you've been up to during yours? You're not just going to the beach and drinking umbrella drinks.
Not really. So yeah, I would start saying I'm not on vacation. So it's not only, so if in academia, hopefully everyone more or less understands, but outside academia, they have no clue. Like, I'm sabbatical, you are on vacation. It's like, no, I have to start like explaining, no, this is this, that. So I would say that this is when professors or faculty, we take some time away from our regular teaching, and we can focus on advancing research, on your or on other topics that allow you to grow generally in your research field. Maybe this can lead to like international collaborations, like in my case, like I'm now working with different teams here at in Barcelona, but it can also be, maybe some people decide to stay at Virginia Tech or at their home institution because they want to concentrate on their current project, or they want to put together a big project that requires a lot of time. So every single faculty decides on where to spend or how to spend this time away from teaching. But at the end of the day, like, the objective is to grow as a researcher. Overall, yeah, I think many things can be included in this, in the work that we do. For me in particular, I just started because I'm leaving for a full year, and this beginning of spring, this beginning of the fall. So, but I will be collaborating with two different teams, one at the Universitat Politècnica de Catalunya and another one at the University of Barcelona, on topics. One is more on, like, I'm collaborating with people from more the mining engineering, and in the other team, I'm more collaborating with earth sciences a little bit more. So I try to improve my toolkit, right, in order to solve like problems related to natural geotechnical hazards and natural hazards and slope stability and stuff like that.
So let's sum it up for everybody out there. Still working, usually not teaching.
Correct.
Doing
usually
research, doing other stuff during the year. So I think that makes it simple for everybody. Alba, you made it through all the questions. You made it through all the follow-up questions. This was great. We went a lot of different places, and hopefully now when people go to Barcelona for that vacation, they know exactly what they should be doing while
Otherwise, you should call me. Just send me an email, and I can
That's a great point. Yes.
Sure.
Very easy. For our viewers, if you liked what you saw, and you probably did because you're here at the end, you should click like, subscribe, get notifications, and yes, we will let you know every time we post something to the YouTube channel, which is usually multiple times a week, so you don't want to miss it. Alba, thank you for doing this, even while you're far away across the ocean, but we talked about that. It's a lot easier than it would have been even 10 years ago. This was pretty simple, pretty fantastic. So thank you for doing this. I hope it was fun.
Thank you, Brad. I enjoyed it.
And again, for all of our viewers, of course, You know what I'm going to say next. We will see you in just 7 days with another brand new episode of Director's Cut.